All right, we're ready to start a new chapter now, and chapter 7 is going to be about graphing. So first, let's just get some terminology. This is a graph, or a Cartesian coordinate system, or just a coordinate system. Cartesian because it's named after the guy that invented, I want to say invented, right? Figured out a handy way to do it, named Rene Descartes. So you can call it a Cartesian coordinate system, or a graph. Okay, so components of the coordinate system, we have our x-axis. Really all it is it's two number lines. Imagine this being a number line, and again, if we had at these tick marks, right? This is 0 right here, etc., etc. Okay, then if we copied this number line and just flipped it perpendicular, it's just two number lines next to each other, is all a graph is. The horizontal one is your x-axis, and the vertical one is your y-axis. If you're talking about both of them, plural for axis is axes. This point right here in the middle where they cross, that's called the origin. Okay, that's the origin. And these three terms represent the exact same thing. We can call them a coordinate, a point, or an ordered pair. An ordered pair is the most descriptive. It tells us that it's a pair of numbers, and the order matters. Okay. However, point is the shortest, so that's what we usually call them, or points, right? But they are ordered pairs. You got them, write them in order. The x has to come first, just like in the alphabet, right? The x part comes first, and then the y part. So the coordinate, or the ordered pair for the origin, is the point 0, 0. It's when x is 0 and y is 0. Positive to the right, negative to the left, positive up, negative down. Okay, the intercepts are points that are on the actual axes, right? The y-intercept means you've got a number on the y-axis. So the x is always going to be 0 because I'm looking at numbers up and down on here. Well, that's when x is 0. So this is the point, the coordinate, okay? 0 for the x, but 1, 2, 3, 4 for the y. Okay, this is the point now on the x-intercept. The x gets the numerical value and the y gets 0 because the x is 1, 2, 3, 4, 5, 6, 7 in the negative direction, -7, but I'm not going up or down any, so the y coordinate, the y part of that coordinate is 0. Okay, so it says plot these points on the coordinate system. So remember, x comes first. You always start at the origin. Origin, another word for origin, is the beginning, right? This is where you always begin when you're plotting points. So if I go over to where the x is 2, okay, I'm doing this one. If I go over to where the x is 2, and then down 1, 2, 3, 4, that's where y is -4. There's that point. Okay, for this one, I start back at the beginning, but this time on the x comes first, so back and forth first. So I'd go backwards, 1, 2, 3, 4, 5, and then down 1. That's the point -5, -1. Okay, if we do this one, okay, I start at the beginning again, at the origin, and x is 0, so it means I don't go right or left at all. I don't move any, I just go up 3. Okay, and then finally, if I start at the origin, x is 7, so I move on the x-axis, 1, 2, 3, 4, 5, 6, 7, but I don't go up or down any. Y is 0, so don't go up or down. So that's plotting these points. Okay, now these two axes divide our region into 4 spots, 4 sections. So they're called quadrants because quad means 4. Okay, this one is quadrant 1, and then we're going to go counterclockwise. So this is quadrant 2, quadrant 3, and quadrant 4. Okay, so this point, 2, -4, is in the 4th quadrant. This point is in the 3rd quadrant. These points, if it falls on an axis, they're not in any quadrant, right? They're on an axis. So if your MyLabs Plus asked you which quadrant this point is in, they're trying to be tricky. Your answer is no quadrant, right? It's on an axis. Okay, so that's a little bit of terminology having to do with graphs. Now the question is, well, why do we have to do graphs? Algebra is always about solving equations. So we started the course with, let's just make it a simple linear equation. And we said, oh, we can solve that. Right? We know how to solve simple linear equations. All right. But now we're going to have equations that have 2 variables. And now I cannot solve it for one answer. The only number that I can add 2 and get 5 is 3. That's the only value that works. But down here, I could say, oh, 3 plus 2 is 5. X could be 3, Y could be 2. Hey, X could be 2, Y could be 3, right? Or 1 and 4 is 5. Or -2 and 7 is 5. Or 1.5 plus 3.5 is 5. Or I could keep going and going and going and going. Okay, so I've got a combination of, I can no longer just have an answer and say, oh, here's your answer. So what we're going to do is we're going to draw a picture of the answer on our graph, right? And put our combinations of X's and Y's on our graph. Okay, you know what they say, a picture's worth 1,000 words. So remember, an ordered pair is XY. That means I could write every one of these. This means X is 3 and Y is 2. Couldn't I write that as the coordinate 3, 2? That's exactly what this means. X is 3 and Y is 2. This one means X is 2 and Y is 3. Right? Here's what X is 1 and Y is 4 looks like. Here's what X is -2 and Y is 7. So let's plot these points. Okay, start at the beginning, at the origin. 1, 2, 3, and then up 2. Okay, this time over 2 but up 3. Okay, over 1 and up 1, 2, 3, 4. Okay, backwards 2 and up 1, 2, 3, 4, 5, 6, 7. Let's do this one, 1.5, 3.5. So over 1.5 and up 1, 2, 3.5. Notice what happens. Hey, all of those points are in a straight line, right? If I connect those points, this is the solution for that equation. It means every single point, every speck on here, look at this one, is a solution. This is the point 0, 1, 2, 3, 4, 5. Plug it in. 0 plus 5 is 5, right? Every single speck on this line is a solution to that equation. And it goes forever. So I gotta have arrows on it. If you don't have an arrow on your graph, it means something. It means it stops right there. So you gotta have arrows. Okay? And notice, hey, these solutions fell in a straight line. That's why we call these linear equations. Linear. Now, notice this is a linear equation in 2 variables. This is a linear equation in 1 variable. If I have two variables, an x and a y, I got to draw a picture of what it looks like. But if it's linear, right, we'll talk about other shapes in college algebra. So I got to get my basics here of graphing on these easy ones that's just a line. And then we're going to build on that for other shapes. But right now, everything's just going to be linear. It's going to make a line. So if I think about that, I had a whole bunch of points here. But if they're all straight lines, by the way, that's redundant. I'm saying it for emphasis. When you say line, it means straight. If the line is not straight, we don't call it a line. We call it a curve. Okay, so a line implies it's straight. All I need to graph any line is 2 points. If I have 2 points, then I can just draw a straight line through it. Doesn't matter if I'd have had that point or that point, right? Any point, I can draw a straight line through it. All right, so that's our goal. All we need are 2 points. And easy points to find are the intercepts, right? Easy points are the intercepts. So we usually, when we're graphing, we make this little T-bar, T-chart, T-diagram, whatever you want to call it, but notice the big T. And we just find some points that satisfy that equation. Any numbers we want, plug a number in, and then see what the corresponding value is that will make this true. The easiest numbers in the world to plug in is if x is 0 and y is 0. Right? That gets rid of a lot of our math. If x is 0, that's gone. So we just have this equation to solve. Oh, negative y equals 4. That must mean, now watch your signs, must mean y is negative 4. Right? Negative, negative 4. Or I could solve this one-step equation and see, oh yeah, y is negative 4. Okay, now let's do the same thing with y. Let's say if y is 0, then 2 times what is 4? That'd be 2. Or, once again, solving a simple equation, x is 2. And when we get 2 points, okay, so 0, negative 4, 1, 2, 3, 4, and 2, 0. Oh, well, then there's what the solution to this looks like. It means any point on here will satisfy that equation going forever, right? So because they're lines, 2 points will satisfy my condition to make a line, and then I can just draw a line through it. The easiest 2 points to find by far are plugging in 0. Okay, so same thing here. Once I see I've got 2 variables, that's my clue, because I need to know when I see an equation. I mean, these are telling us, okay, graph this equation, and it's also telling you how. But I'm not always going to have instructions. I might just have this equation and it says solve it. And I'm like, oh, okay. Well, to solve this equation, I got to know what kind it is. I see 2 variables. Anytime I have x's and y's, I'm drawing a graph. I can only solve an equation with 1 variable in it, right? Okay, so I'm going to find my intercepts. Let's let x be 0 and then y be 0. Because if x was 0, this would be gone. 4 times 0, this would be gone. And 3 times what is 12? Oh, okay, 4. So that's the point there. Let's do the same thing and imagine, well, what if y was 0? That would be gone. 4 times 3 is 12. There's 2 points. That's all I need if it's a linear equation and 2 variables, right? So here's the point 0, 1, 2, 3, 4. Here's the point 1, 2, 3, 0. You draw a line, hopefully straight, that goes through them. Put arrows on both ends, and that's what your solution looks like. We just solved this equation, right? We solved this equation. It's the combination of x's and y's that fall on that line. Okay, let's try it again. Because I have an x and a y, I know I'm graphing, which means I know it's going to be a line because it's linear. If x is 0, y is, 6 times what equals negative 10? Hey, but don't forget, oh, well, just use my method. One-step problem. Okay, so y is negative 10 6, which negative 10 6 is, both of them are divisible by 2, so negative 5/3. Now, if I'm graphing, I might want to change that to a mixed number just so I can tell where it's going to fall on my number line. Okay, let's do the same thing for y now. If y is 0, oh, this one's easy. 5 times negative 2 is 10. But if it's not a whole number, and it's like, what is that? I can just solve like we did up here. It's a one-step process still. Okay, 0 and negative 1 and 2/3. So 0, negative 1 and 2/3. About right there. Just 2/3 of the way between 1 and 2. And then negative 2, 0. Connect the dots. Don't forget your arrows. And that's what the solution looks like. Okay, we're still graphing because we have an x and a y. So I'm going to try to find my intercepts. So if x is 0, now watch signs. Negative 3 times what is positive 6? Negative 2. I need two negatives to be a positive. Watch your signs. Okay, now if y is 0, 2 times what is 6? 2 times 3 is 6. Okay, so 0, negative 2, and 1, 2, 3, 0. Draw a straight line between them. We're good to go. Awesome. Okay, let's do this one more time. Okay, if x is 0, negative what is 0? 0, right? Negative 0, positive 0, same thing. If y is 0, let's look at that. Let's look at what that tells us. If y is 0, pen please. If y is 0, 3 times 0 is 0. I didn't get two different points. I know that 0, 0's on there, but I have to have 2 points. That's okay if it goes through the origin and your x-intercept and y-intercept are the same value. Just try to find another point. Plug in anything you want. Let's plug in and let x be 1. Okay, so if x is 1, I'm going to plug it into that equation and solve it. 3 times 1 minus y equals 0. 3 minus y equals 0. Let's subtract 3 from both sides so that we have minus y equals minus 3. Right? Divide by negative 1, divide by negative 1. So y is positive 3. If x is 1, y is positive 3. So if I wind up with just 1 point by doing my intercepts, I can find any other point I want. Plug a number into one of those, it doesn't matter, and then solve the equation for the corresponding value. So now I have 1, 1, 2, 3. Okay? Just imagine I'm drawing straight lines, guys. Okay. All right. Now, once we realize every one of these lines is straight, the only difference in any one line and another, besides where it's located, is its slope. right? So slope is the ratio of rise to run. In other words, if you're at one point, then how far up you go compared to how far over you go to get back on the line, we call the slope. If I'm on a graph of a line, I can just count. This doesn't have any numbers, so I'm just going to kind of make up. Okay, I'm going from this point, I'm going up 1, 2, 3, let's say, if that's compared to over 1, 2, 3, 4. And that's how I would find the slope. I just count rise. Oh, it says it right here. Rise over run. Rise over run. Rise over run. Or you might think of it as y's over x. Rise or y's go on top. Right? Rise over run, y's over x. Okay? So technically the change in y. So here's a formula for us that we got to memorize. M equals the difference in your y's over the difference in your x's. Right? Now, these subscripts just tell us, they're not telling us the order we have to subtract them in. They're telling us we have to subtract the x's and the y's in the same order. It doesn't matter if I'm trying to find the slope between these points or these points, right? It better be the same slope. It's the same 2 points. It's going to be the same line. So it's not telling us to use the second point first. It's just saying do them in the same order, whichever that is. So let's practice that. You got to memorize that formula. Okay, so I'm going to write it down here for us. That formula, let me see if I can write it up here, is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, so this is saying find the slope of these 2 points. Okay, anytime I have 2 points, I can find the slope of the line that goes through them. Okay, I'm going to pick my y value, and I pick them in a way that makes my math easier. So I'm going to start with this one. 9 minus, there's a minus in the formula, now the other y. Now be careful and account for all the negatives. There's a minus in the formula, and this number has a minus, so I got to have both of them in there. Because I started here with my y's, I have to start here with my x's. So -6 minus the other x. Okay, so minus, this is really plus, right? 9 plus 5 is 14. Okay, signs are the same, so we're going to add these numbers. -6 minus 3 is -9. It will not reduce. There's the slope of the line that goes between those 2 points. Let's do it again. Okay, y minus the other y value. Because I started over here with my y's, I got to start over here with my x's. Minus the other x value. Got to keep track. X, y, x, y. So 6 plus 4 is 10. That's why to me it's easier to do it in that order. 2 minus 1 is 1. Don't forget to simplify. Okay. Okay, this one it doesn't matter. Oh, look. 4 minus the other y value. I started over here, so I got to start here. -4 minus 2. So 0 over -6. Don't forget to simplify. Okay. One more. 1 minus -5 over 3 minus 3. 1 plus 5 is 6 over 0. Hey, do not leave that. Remember what we say when we have a 0 in the denominator. We call this undefined. And that's what we're going to call the slope. We call that an undefined slope. Okay, these two right here are special situations. If your slope is 0, it means that's a perfectly flat horizontal line. It doesn't have any slope. The slope is 0. It's flat. It's not sloping. If the slope is undefined, it's perfectly vertical. It's so steep. Imagine that's a straight line. It's so steep, I can't even define it. Right? Everything about these two lines as we go through are going to be what I'm going to refer to as special. They have special slopes. Their graphs are special. Their equations are special. Okay? So whenever I see any of those that correspond to our two special situations, okay, all the other stuff I'm just going to kind of throw out the window and say, oh, wait, special, and place it together. Okay, we'll look at that as we go. Hopefully, that'll make more sense when we're actually doing it. Okay, here we're talking about those special equations. Okay, now remember, the whole reason that we are graphing is because we have two letters now, an X and a Y. However, if we are graphing and we're being told we're graphing and we only have one letter, like Y equals 3, I got to recognize, hey, that's special. If I'm drawing a graph, I need an X and a Y. So if I only have one letter, Y equals 3 or X equals 5, I got to recognize special, and I just got to think about what that means. If my equation has the Y in it, it means the line is horizontal and it's not going to slope at all. In other words, here's my graph. This is the Y-axis. It's going to go through the Y equals 3 tick mark, right? That's going to help me. Oh, the Y is 3. There's the tick mark on the Y-axis. It's 3. So my line must be horizontal. If it's horizontal, my slope is 0. Anytime I know any one of these things, I know all three of them. If I have an equation with one variable, I know what the line looks like. If I know what the line looks like, I know the slope. If I know the slope, I know what the line looks like. If I know what the line looks like, I know what the equation looks like. So with this one, if X is 5, here's my X-axis. So 1, 2, 3, 4, 5. Here's the little tick mark when X is 5. Oh, well then, if I just extend it, this is everywhere that X is 5. That's a vertical line and an undefined slope. All right, I just got to memorize that stuff. All the special circumstances. Okay, so graph each equation. Hey, I only have one letter. It's special. So here's my y-axis. Whoa, funny that I use that same one. 1, 2, 3. Right? There's the little tick mark where y is 3. So if I want to graph it, that tells me just extend that. Now that I'm looking at the graph, what's the slope of this flat thing that doesn't go up or down any? The slope is 0. This one, I also have to recognize it just has one letter. Oh, that means it's one of my special graphs. Let's solve it for the letter. I want it to be x equals -2. Now, here's my x-axis. So when x is -2, there's the tick mark that corresponds to when x is -2. Okay, so this is a vertical line. And if it's vertical, the slope is undefined. Right? It's so steep. I cannot climb it. I cannot define it. I cannot anything. Except draw it. Right? Okay. Got to keep that in mind. Those special situations. Okay. graph the line. I got an X and a Y this time, so it's going to be normal. So I'm looking for my intercepts. If X is 0, -2 times -6 will give me 12. Okay. If Y is 0, 6 times 2 will give me 12. All right, so there's my 2 points. 0, -6, 1, 2, 3, 4, 5, 6. 2, 0. So there's the graph. And it says find its slope. If I'm looking at the graph, I need to find 2 points, make sure it's actual points that the graph goes through, and then I just do rise over run. So if I start with this one, I go up 1, 2, 3, 4, 5, 6. I go up 6, and then over 1, 2, over 2. The slope of that line is 3. So if I'm looking at the graph, finding the slope's really easy. You just count up and over. Right? Now, with that being said, when you're going down or backwards counting, then you put a negative up here, right? And really, it doesn't matter which point you use. Look at this. Okay, so I start at any point, but to get back to this other point, I would have to go down. 1, 2, 3, 4, 5, 6. Down is represented with a negative. And then backwards, 1, 2. Backwards is also a negative. But a negative divided by a negative, you still get the same answer. So it doesn't matter which point you start with, just like in the formula. Right? Okay. Now this, really, we're going to investigate this a lot more in the next section, but let's go ahead and give us an idea. Find the slope of this graph, but it doesn't say graph it and find the slope. So it turns out an interesting thing is if I solved this equation for y, so let's do that. If I'm going to solve it for y, remember we've practiced solving for variables many times. This is the main reason why. Okay, so I would have 4y equals, and we generally going to put the x first, 3x plus 9. Okay, so I just moved the 3x over. Now I'm going to divide by 4 because I need it to be just y equals. And let's divide each one by 4. So y equals -3/4 x plus 9/4. If I have an equation solved for y, this number in front of the x, the coefficient of the x, that is my slope. Not including the x, a slope is a number. Right? Just the numerical part of that term. That's going to be huge for us next time. I think you've just got a problem or two on this section, but next time we're going to look at this a whole lot more. Okay, oh, we got one more to do. Okay, so if I'm finding the slope of this, I want to solve it for y. Solve it for y. So I have -5y equals -2x plus 7. Solve it for y until you get the y all by itself. So then you have 1y equals a negative. Negative is a positive. A positive negative is a negative. Okay? And then whenever it's y equals and just one y equals, the coefficient of the x term is your slope. Okay, graph the line passing through the point -3, -2. Okay, if it goes through -3, 1, 2, 3, -2, it goes through that point. It has a slope of 1/2. Hey, that means there's got to be another point up 1 and over 2. up 1 and over 2, I can get a whole bunch of points real quickly. If I know the slope, up 1 and over 2. Up 1 and over 2, over and over and over. I only need 2, but if I know the slope and any point, I can also graph that line. So I don't even have to be given the equation if I know the slope. Okay, let's try that again. Slope 0, special. So I got to think about what that means. Okay, it goes through the point -1, 5. 1, 2, 3, 4, 5. And what does it mean if the slope is 0? Oh, that means your line is horizontal, flat. So I also know the equation of this line, right? Which I didn't know the equation of that other one, but these special ones, this is y equals 5, right? So where the y is 5. So when I see any of those conditions that make it special, a slope of 0 or undefined, an equation with one letter, or a graph that's horizontal or vertical, I know all bits about that situation. Okay, so here's the 4 things that can happen with your slope. If your slope is positive, a positive number, 3/4, your line will slope up, which, by the way, I always get people saying, well, it's going up that way, but down this way. But you read in this direction, right? From left to right. You read a graph the same way. So if I'm going this direction to read the graph, once I get on it, it goes up if I go in that direction. This one, once I get on the graph, it's going down if I keep going that direction. All right, so if your number is positive, your line will slope up. If your number is negative, your line will slope down. Okay, if the slope is 0, it's horizontal. If it's undefined, it's completely vertical. Okay, so this is a nice check too. If you wind up with a negative slope, your line better be going down. Okay, while we talk about slopes, just kind of an aside thing comes in. What about parallel lines and perpendicular lines? Now we're talking about comparing 2 lines. Remember what parallel means. Parallels, like railroad tracks, right? They go the exact same. They never, ever, ever cross. That means they're parallel. The only way that can happen is if they're sloping exactly the same amount. If I had this line and then another line sloping a little bit different, eventually it's going to cross that line, right? The only way that a line could not cross this is if it was sloping exactly the same. So parallel lines have the same slope. Okay, perpendicular lines means they cross like this. Let me actually change colors to talk about perpendicular. Perpendicular lines means they cross at a 90-degree angle. They don't have to be like that. It could be like this, but just that's 90 degrees. Okay, they have slopes that are negative reciprocals. Negative reciprocals. Remember what a reciprocal is? It's when you flip the fraction upside down. So if one of your slopes is positive 2/3, if the other slope of the other line is negative 3/2, those lines will be perpendicular. Okay, parallel slopes, parallel lines have the same slope. Perpendicular lines have slopes that are negative reciprocals, complete opposite of each other. So, if I want to know if these 2 lines are parallel or perpendicular or neither, right, the line that passes through these points and this other line, I need to find their slope. Anytime it's asking you about parallel or perpendicular, you need the slope, right? So let's find the slope that goes between, or that, of this line. Okay, so this time I'm going to start with this point just because 5 minus 2 is positive. I like that to be positive. Whatever math I'm doing. Okay, because I started over here, now I got to start over here on my x's. So 3 minus 1. 5 minus 2 is 3. 3 plus 1 is 4. All right, let's find the slope of the other line. Okay, 10 minus 7. Because I started over here on my y's, I got to start over here on my x's. So 8 minus 4. 10 minus 7 is 3. 8 minus 4 is 3. Hey, these slopes are identical. These lines are parallel. Okay, that's a shortcut for parallel you can use. This is the shortcut for perpendicular. I don't want to write it down there. This is my answer. The lines are parallel because they have the exact same slope. They are sloping exactly the same. They can never cross each other. Okay, same question, parallel, perpendicular, or neither. So all I need is the slope. Remember, when I see two equations solved for y, this is the slope of that line, and this is the slope of this line, the coefficient of the x. So now, are they exactly the same? Nope. Are they reciprocals? Well, negative reciprocals? Well, one's positive and one's negative, but they're not reciprocals, right? The reciprocal of 2 would be a half. So these are neither. They're not parallel nor perpendicular. Okay. This is just like that question we just answered, but I got to solve to figure out the slope. That other one was already solved for y, and I could just look at it. So I'm going to take each equation. So first of all, I'm going to take the top one, solve it for y so I can tell what the slope is. Okay, 5y equals negative 3x plus 6. Divide by 5, divide by 5. At this point, I can stop because I know what the slope is, right? The slope of this line is negative 3/5. Now, if I was trying to find the equation, I can't just leave this nasty stuff like this, but I don't care about the equation. I'm looking for the slope, and now I have found it. So let's do it. Same thing to the other equation. Okay, let's solve it for y so we can see what the slope is. Okay, so basically I've got it solved for y, so I know the slope of this line is a negative. Negative is positive 5/3. Okay, one's positive and one's negative. 3/5 and 5/3, hey, these things are perpendicular. They have negative reciprocal slopes. One more. Woohoo, word problem, right? Okay. There were approximately 45 million digital cable TV customers in 2010. Using this number for 2010 and the number for 2012 from the graph, okay, so here's our graph, okay, how does it compare to the average rate of change found in example 10 from the text? Well, we're not going to be able to compare that, but let's just find the average rate of change. Okay, it says find the average rate of change. Anytime a problem asks you to find the average rate of change, it just says, might as well say find the slope. The average rate of change is the slope of this line. The average rate of change is the slope of this line. So it gives me 2 points here. Here's a point and here's a point. But it tells me to use this point, right? 2010 and 45 million. So it tells me to use this point. It really doesn't matter. The slope's going to be the same because it is a line, right? So it tells me to use 2010, 45, and then the number for 2012, which is 47. So 2012, 47. All right, and the slope is simply your y values, the difference between your y's and the difference between your x's. So this is 47 minus 45. Because I started over here, I got to start over here with this one. 2012 minus 2010 equals 2 over 2, 1. Okay, so anytime something's asking you to find the average rate of change, it just means find the slope. Okay, then you could compare it to the slope of whatever other problem it wants you to do. Okay, good luck.